Have you ever copied the same algorithm into 3 different classes and changed just 1 or 2 lines and told yourself, it's fine, I'll refactor it later? Yeah, we both know you won't. Today, I'm gonna show you a pattern that lets you define the skeleton of an algorithm once and allow subclasses to customize only specific steps without duplicating the whole thing. By the end of this video, you'll understand what the template method pattern actually solves, know exactly when to use it and when not to, implement it cleanly in C#, and most importantly, start writing code that looks like it came from a senior developer. This video is part of my series Design Pattern Code Like a Senior Dev. If you haven't watched the earlier episode, especially Strategy and Straight, pause this, check them out, and then come back. We are building your pattern intuition layer by layer. Now, let's level up. Let's imagine something relatable. You're building a system that processes different type of files, CSV files, XML, JSON files, and each one follows the same overall steps. Open file, parse content, validate data, save to the database, and then log result. Now here's the issue. Parsing is different for each file type. Validation rules may vary slightly, but everything else exactly the same. So what do most developers do? They copy paste the entire process into 3 different classes. Fast forward to 6 months. You need to change logging. Now you have to update the same code in 3 places. Miss one, production bug. Classic. So the real problem is that the algorithm structure is fixed. Only a certain steps vary. And that's where template method shines. Template method pattern says, define the skeleton of the algorithm in the base class. Let subclasses override specific steps without changing the overall structure. It's about controlling the flow in the parent class. Think of it like a cooking recipe. The recipe defines preheat oven, prepare ingredients, bake, and then cool down. But the ingredients differ depending upon if it is a pizza or a cake. The structure, that remains fixed. The steps inside can vary. That's template method. And now let's implement it properly in C#. Alright, let's implement the template method pattern step by step. I'm going to start by creating an abstract class called file processor, and I'll implement it real quick. Now, let me explain what's happening here. First, notice the class is marked abstract. That means we can't instantiate it directly. This class is meant to define the structure of the algorithm. Now focus on the method process file. This is the template method. Now this method defines the exact sequence of steps required to process a file. Open file, parse file, validate file, save data, and then log result. And very importantly, this method isn't virtual. This is intentional. We do not want subclasses to change the order of the operations. That's why we kept it non-virtual. Now let's look at the individual steps. We have the first one that we are calling open file. Now this is protected and virtual void method. That means subclasses can override it if they want, but they don't have to. Then we have parse file. Notice this one is marked as abstract and not virtual. This is because we must implement this method in each subclass, because parsing logic would be different depending upon the type of file. Same idea applies to the validate data, save data, and log result. They all are virtual, meaning that they have a default behavior but can be customized if needed. The base class defines the structure. Subclasses would define the variations. Now let's create a concrete implementation. I'll create a CSV file processor now. Here, we override the parse file because it's abstract and we must implement it. For CSV files, parsing logic would be different from XML or JSON. Also, notice something important. We didn't override any of the open file, validate data, save data, or log result. That means the class would use the default implementations from the base class. Now, let's create another implementation. This time, it would be XML file processor. Here we override parse file again, and this time we also override validate data. Why? Because XML validation might involve schema validation, which is different from a simple CSV check. Everything else, opening the file, saving data, logging, remains unchanged. Now let's quickly test this out. So for testing, I'll go to the top of file and put my code here. Okay, I'll just reformat it. Okay, cool. So now I'm creating a file processor called CSV processor and instantiating it with CSV file processor, and then I'm calling process files. I'm doing the separator for separating these two outputs, and then I'm creating an XML processor and instantiating it with the XML file processor and calling process file on that. Let's run this and see what happens. So, okay. So opening file, parsing CSV file, validating data, saving data to database, and logging results. So this follows the steps that are provided in process files as it is, and that is good. And if you look at the XML one, you see opening file, parsing XML file, then validating XML schema, which was the overridden method that we created, and then the similar thing. So let's say in some days I want to change the way log result works. I just need to change only in the base class and it would reflect everywhere, which is handy. That's the template method pattern. We define the skeleton once, we allow controlled customization, and we enforce execution order at the architectural level. That's how experienced developers think about extensibility. So here's what you gained. Centralized algorithm control without duplication, with safe extension points, and clean separation of invariant versus variant behaviors. This pattern enforces structure. It prevents inexperienced chaos. So, the question is when not to use it. Template method is inheritance based. If you need runtime switching of behavior, use strategy instead. But if you have too many subclass combinations, you might create inheritance explosion. Use it when the algorithm structure is stable, variations are limited to certain steps, and you want strict control over the execution order. You may ask, what's the mental model for this? Whenever you see something like this workflow is always the same, only the one step changes, or you find yourself copy-pasting the structure, that's your brain screaming, template method. At the start, I promised you would understand the problem it solves, implement it in C#, know when to use it, and think more like a senior developer. And now you can. You have seen the problem, the concept, the implementation, the edge cases, and the trade-offs. You're not just memorizing pattern, you're building architectural instinct. And that's important. And that's what separates senior developer from a normal developer. This video is part of series Design Patterns Code Like a Senior Dev. We have already covered strategy, observer, state, and we are systematically building your pattern toolbox. If you want to go from I can code to I design systems confidently, watch the full playlist. If this clicked for you, drop a comment. In the next episode, we are dividing another pattern that senior engineers use without even naming it. Until then, code intentionally, design deliberately, and I'll see you in the next one.